Now we have graphing inequalities, which is basically the same thing as graphing equations, except we have to shade. So for this first one, we know that our slope is going to be -5/2, and our intercept is -1. So first I graph my intercept on the y-axis. Then my slope is -5/2, so that means I go down 5, right 2, or up 5, left 2. Now, one thing with graphing inequalities, we have to decide if it is a shade or a dotted line or a solid line. So if you have one of these two, that's a solid line. But if you have one of these, that's a dotted line. So on this one, we have that equal to line underneath it, so we're going to draw a solid line between our dots. And now we just have to decide which way we're going to shade. So we have y is greater than, so anytime it's greater than, that means we shade above the line. So that would be up here. If you're not sure which way is above or below, we can pick a test point. So I'm going to pick 1, 1 in this case. And if I plug in 1, 1, that means my y is 1 and my x is 1. So we have a coordinate x is 1 and y is 1. So I replace x and y in this equation with 1 and 1. So -5/2 times 1 minus 1. So 1 is greater than -5/2 minus 1, which would be 1 is greater than or equal to -7/2. So this one is positive and this side is negative, so that is a true statement. So if you plug in a test point and it gives you a true statement, you shade the side with that test point. So since this was true, I shaded the side that included 1, 1. If this gave me a false statement, I would shade the side that the test point is not included in. Now it wants us to figure out if these over here are solutions. So I'm going to plot each of these points to see if it falls in the shaded region. If it's not in the shaded region, it's not a solution. If it is in the shaded region, it is a solution. So first I have -1, -1. That point right there is not in our shaded area, so it's not a solution. 0, 2. That one is in the shaded area, so B is a solution. -2, -1. Not in the shaded area, so not a solution. And 0, -2. Also not in our shaded area, so B is the only solution there. Now for 47, this one is not in slope-intercept form, so we're going to have to manipulate this to get it to look like this one. So I have x minus 2y is greater than -5. To get y by itself, I have to subtract x from both sides. So I end up with -2y is greater than -x minus 5. But then I'm going to divide everything by a -2. But remember, with inequalities, if you divide by a negative, you have to flip this sign. So this is going to become y is less than -1 divided by -2 is +1/2 x. -5 divided by -2 is +5/2. Now +5/2, if you convert that to a decimal, you get 2.5. So to graph this, our intercept is going to be right in between 2 and 3. So I'll put my first point there. Then our slope is 1/2, so I go up 1, right 2. Or I go down 1, left 2. Now if we look down here, this one does not have the line underneath it, so this will be a dotted line between these points. So it is not going to be equal to. And since its y is less than, we can shade below the line. So less than is below the line. But again, if we're not sure, we can use a test point. So I'll pick 0, 0 this time. So if I plug in 0, 0, I make y a 0 and x a 0. So anything times 0 is 0, which means we have 0 is less than 2.5. That is true, so we shade the side with the test point. So we did that part correctly. Now let's test which one of these is a solution. So 0, 0, we just had that point. Is that one a solution? Yes, because it's in the shaded area. So A would be a solution. 0, negative 5. So 0, negative 5. So 1, 2, 3, 4, 5. That one is also a solution because it's in our shaded area. 5, negative 5. 1, 2, 3, 4, 5. That one right there is also a solution because it's in our shaded area. So 0, 1, 2, 3, 4, 5. That one is not in our shaded area, so not a solution. So A, B, and C are all solutions to this one. Now if we go down, we have a word problem of inequalities that we need to figure out. So it says, at a pancake breakfast, children are served 2 pancakes, and adults are served 5 pancakes. Together they can be served at most 117 pancakes, the total made by the chef. Write an inequality to represent the pancakes that could be served at the pancake breakfast. So we're going to first define some variables. So I'm going to say C is for children, A is for adults. So we know that each child gets served 2 pancakes, so that would be 2 times the amount of children. And then it would be 5 pancakes for adults, so 5 times the amount of adults. And they can be served at most 117. So at most means that this number over here cannot be more than 117. So we have to say 2C plus 5A is less than 117. But it could also be equal to 117, so we put the equal sign underneath our inequality. So this right here would represent the inequality that they gave us.